Leaving groups are very important in organic chemistry. You're going to see many examples of reactions involving the loss of a leaving group. Loss of a leaving group is when the leaving group takes 2 electrons. These 2 electrons go with the leaving group, giving the leaving group a negative charge, leaving behind a carbocation, a carbon with a positive charge. This is the first step of an SN1 process. This is also the first step of an E1 process, and there are many mechanisms that you're going to see in your year of organic chemistry that involve loss of a leaving group. So we need to recognize that there are 3 different categories of leaving groups. We have excellent leaving groups, we have good leaving groups, and we have bad leaving groups. If you have a compound that has an OH group and we protonate the OH group, in other words saying put another proton on this oxygen, that gives us a positive charge on the oxygen. The oxygen has 2 protons and a positive charge. This here is now an excellent leaving group. And this is our first category of leaving groups. This is an example of an excellent leaving group. Why? Because when this oxygen takes these 2 electrons and leaves as a leaving group, these 2 electrons, the positive charge is now here on the carbon. This is a carbocation. The leaving group that left does not have a negative charge as we saw before. Why? Because the leaving group started already with a positive charge. So when it takes these 2 electrons, it quenches that positive charge and you're left with water. You're left with water, leaving behind a positive charge on the carbocation. And therefore, this leaving group, because it can leave neutral instead of leaving with a negative charge, this is an excellent leaving group. This is our first category of leaving groups. Excellent leaving groups are leaving groups that can leave without a negative charge. Now, the next category is good leaving groups. Good leaving groups, for example, a chlorine is a good leaving group. Why? Because when the chlorine takes these 2 electrons, when it takes these 2 electrons and pulls them away, now this is not going to be an excellent leaving group because it's not neutral, it has a negative charge. But the negative charge is stabilized because chlorine is an electronegative atom. And therefore this is a pretty good leaving group, albeit not excellent, but still good. And there are many examples of good leaving groups. Bromide is also a good leaving group, iodide is a good leaving group, and tosylate. You're going to see tosylate a lot. This whole group right here is one big leaving group. Let's see what happens when it leaves. These 2 electrons here are taken, leaving a negative charge on the oxygen, positive charge on the carbon. This negative charge is stabilized by resonance up onto this oxygen, resonance up onto this oxygen. So this negative charge is stabilized, is spread out over 3 oxygen atoms, spread out by resonance over 3 oxygen atoms. And that makes the negative charge very stabilized. And because the negative charge is stabilized, this is a good leaving group. The third category of leaving groups are bad leaving groups. For example, if you have an OH here, we've already seen that if you protonate the OH, you turn this into an excellent leaving group because when it leaves neutral. But if you don't protonate the OH, now it's a very bad leaving group because when you take these 2 electrons and pull them over onto the oxygen, you form a carbocation, and here is your negative charge on an oxygen not stabilized as it was before. Although oxygen is an electronegative atom, but nevertheless the halogens are much better at stabilizing the negative charge than the oxygen. In general, hydroxide is not a good leaving group. It is considered to be a bad leaving group. There are some exceptions that you will see where hydroxide can function as a leaving group, but for the most part, as you begin learning reactions, you will not see hydroxide functioning as a leaving group. Not in substitution reactions and not in elimination reactions. So overall what we've seen is that we have three kinds of leaving groups. We have excellent leaving groups, we have good leaving groups, and we have bad leaving groups. Examples of excellent leaving groups are leaving groups that can leave neutral. For example, if you have an OH group which you protonate, this is now an excellent leaving group. Good leaving groups are chlorine or a tosylate group. We saw the entire structure of the tosylate before. Very often it's just written as OTS. Bad leaving group is OH. OH is a bad leaving group. Also, NH2 is a bad leaving group. When you protonate an OH, you convert it from being a bad leaving group into being an excellent leaving group. Similarly, if you protonate an NH2 group, you convert it from being a bad leaving group into an excellent leaving group. And these are our three categories of leaving groups. Let's get some practice identifying leaving groups. The following skill building exercises are designed to help you identify leaving groups as being either excellent, good, or bad.